In finding arc length and sector area, it's going to be important to recognize parts of a circle. So in finding arc length, we're not trying to find the whole arc or circumference of the circle. We're just trying to find a part of the arc length of the circle. If we wanted to find sector area, we're not trying to find the area of the whole circle. We're trying to find just a small portion of the area of the circle. So to better understand arc length and sector area, let's focus on finding parts of a circle. Here we've got a circle with a degree measure of 360 degrees. Let's say we just wanted to find the part of the circle that had a degree measure of 180 degrees. Well, to figure that out, we can just set up 180 over the whole circle, 360, which is going to simplify to 1/2, which you might have already known that 180 degrees is half of a full 360 degree circle. Let's say we wanted to find the part of the circle that's only 10 degrees. 10 degrees, well, to find that, we just put 10 over our whole circle of 360, and that's going to give us 1/36 of the big circle. We can do the same exact thing if we're using radians. Here we have the full circle, which we know is 2 pi. Let's say we wanted to find all the way with an angle of measure of pi. We can do the same exact thing. We'll put pi over 2 pi, which will give us half the circle, which we might have guessed because pi is the same as 180 degrees. How about if we wanted to find all the way to with an angle of 3 pi over 2? We can do the same exact thing. Let's do 3 pi over 2. What is that out of the full circle, which is 2 pi? Now, you should know how to do this, but if not, I'll help you simplify this real quick. Remember, you could put this over 1, then you'd end up multiplying 3 pi over 2 times 1 over 2 pi, which would give us a final answer of 3/4. So we know that that is giving us 3/4 of the circle. Let's do an example involving parts of circles in order to find arc length and area of a sector. Here we want to find the arc length and area of the sector given the central angle and the radius. So we've got a radius of 4, and we want to find these things based on the central angle of pi over 3. Here we've got our circle with radius of 4. So let's go ahead and start by first finding the circumference and area of the whole circle. So first, to find the circumference, we know the circumference of a circle is 2 pi r. So if we plug in our radius, that's going to give us a circumference of 8 pi centimeters. Likewise, if we want to find the area of a circle is pi r squared, so we plug in 4, and we're going to get 16 pi centimeters squared for our area. Next, let's go ahead and find out what part of the circle we're dealing with. We're dealing with the part of the circle that has an angle of pi over 3. So pi over 3 I know is somewhere around here, pi over 3. Now it's not necessary for you to draw this picture, but I'm just drawing to help you visualize it. So we want to find the arc here and the area that's inside this sector. So remember, to find what percentage, what part of the circle we have, we're going to go ahead and set up our angle pi over 3 all over the whole circle, since we're in radians, which is 2 pi. And this is going to give us a part of the circle of 1/6. Okay, so we found the circumference of the whole circle, 8 pi. We found the area of the whole circle, 16 pi. And we found what part of the circle we're dealing with, which is 1/6. So if we want to find the arc length, that's going to be this arc right here. Well, we know this arc is 1/6 of the circumference. So we can just do 1/6 times 8 pi, which is going to give us 8/6 pi, or we can simplify that to 4/3 pi centimeters. Next, we want to find the area of the sector. That's the area of this sector all in here. And we know the whole circle has an area of 16 pi. The part of the circle we want is 1/6. So we'll just do 1/6 times 16 pi, and that's going to give us 16/6 pi, or we could simplify that to 8/3 pi centimeters squared.